Let's begin this lecture with an exercise. We want to spawn a Niagara system where we'll use a basket pedal. So for this, I want you to deduce a way to call the spawn system at location function, and then attempt to create and spawn the Niagara system by yourself before we continue. Okay, to begin, I have the basket header and source files open in Visual Studio. We will spawn the particles in the handle pedal destruction function. To save some time, we can copy what we have done previously from the Apple base header and source files, and we will start in the header and we will copy the pointer along with the uProperty decoration and paste that in the basket base header. Let's change the name of the pointer to pedal lost particles. For this pointer name, I've chosen not to use pedal destroyed particles. We have to think ahead here. At some point in the future, you may want to modify the game to hide the pedal instead of destroying it. In that way, you can unhide the pedal again when you collect some bonus that spawns into the level, for example. So again, with this, we have to think ahead and think about how we may want to extend the project in the future, even though the code is not set up for that right now. The logic to spawn the system will be similar to what we do here in the destroyed function in the Apple base source file. So let's just copy that. Back in the basket base source file in the handle pedal destruction function, if we have that popped element, then do this logic to spawn the particles. We can use the format document feature to format these lines for us. And of course, we need to include the Niagara function library header. Let's replace all of those Apple destroyed particle instances with our pedal lost particle pointer. For the location, we don't want to use the current location of the actor, we want to use the location of the particular component, that is the particular pedal that we have lost. So from the popped element, we can get the component location. This will return an F vector. So let's create an F vector and give that some name such as pedal location. Now we can pass in that pedal location for the location where we want to spawn the system. We can also destroy the component before we spawn the particles. Since we already have the pedal location and we want to spawn the particles in place of the lost or destroyed pedal, let's build and run. We don't have a Niagara system set up for this yet, so let's create one as before. Some repetition allows us to remember these steps. Let's select New System from selected emitters. Select the upward mesh burst as before in the previous lecture and click the plus button to add that emitter. Click Finish to create the Niagara system asset. And I will name this pedal lost particles. Save all, and let's open that asset. We need to specify the mesh element, so let's select the mesh renderer, and in index 0 under the meshes section, let's choose our pedal. Next, in add velocity, I will choose a linear for the velocity mode, and we can reduce the velocity in Z to around 25. Then in initialize particle, let's reduce the mesh uniform scale min to 0.3 and max to 0.7. Then under spawn burst instantaneous, let's reduce the spawn count to something like 3. I won't change anything in the emitter state. Let's press play, and in the preview window, we can now see that we get a cube spawned. This won't really give us the effect that we want a pedal-shaped particle, but let's use this for now, compile and save. We have here to assign that Niagara system, so open up the basket blueprint. Under class defaults, search for our particle effects category, and assign our pedal lost particles asset to the pointer, compile and save. Playtest, and if we lose an apple, notice that the effect seems to spawn in the correct location, but we get those cube particles. We want those particles to reflect the pedal as I mentioned, and they do not currently. The reason for this is that if we drag in an instance of the pedal static mesh asset, we get a cube. We made that work as a pedal by scaling it in the basket blueprint. We can use the modeling tools in Unreal to bake or keep a modified scale of the pedal asset. To begin, let's make sure the pedal instance is selected in the viewport. Next, we will scale that to the size we want for the pedal, so 1 in X, 2 for Y, and 0.75 in Z. Switch over to the modeling mode and scroll down to the transform section. Click on the Bake RS tool. We can use this to bake the rotation and scale. Note that this will modify the actual asset in the project content folder and not just the instance in the level, as I mentioned before, so click accept. Now we have an asterisk on the pedal asset in the content folder, so let's save those changes. Now if we drag in an instance of our pedal is the shape that we want, delete those instances and go back to the select mode. If we play now, the pedals will be stretched out like this. That's because we scaled the parent pedal in the basket blueprint. To fix that, let's head over to the basket blueprint. In the viewport we can see those pedals. And with the first pedal selected in the actor component hierarchy, let's reset the scale property in the transform. Now we get the default pedal static mesh scale. If we play now, the offset seems a bit much here, so let's go back to the basket blueprint. In the class defaults under setup, let's modify the pedal offset. Set the Z value to 125 for example. Compile and save. Play, and that looks better. Also notice that the pedal destroyed particles that get spawned when we lose a pedal now uses that updated pedal mesh, so the particle shape actually reflects our pedal. We may want to reduce the lifetime of those particles and also reduce the amount of floating that we get, which is that velocity property. So back in the pedal lost particles, with initialized particle selected, I will reduce the lifetime min to 1 and max to 2. If you want, you can also reduce the velocity and add velocity, that is the Z value, maybe reduce that to 20. Although 25 or 30 should be fine, it's going to depend on the effect that you want. Compile and save. If we play test, this is what we get now. Now we can iterate on this, so let's go to the Niagara folder, right click on the pedal lost particles and rename that. Postfix_v1 for example, so we'll do a different version of the system. Duplicate that and name the new asset pedal lost particles _v2 and open that asset for editing. In scale mesh size we have these templates. We can modify the curve manually, but we'll stick to using the templates for now. Our mesh is basically scaled according to this curve, using a scale factor. You can click on a template to modify that curve, and you will notice a change in how the mesh scales, that is over the particle's lifetime. With this default template, with this curve, the mesh will begin by scaling up and then it will scale down again towards the end of the lifetime of the particle. And with this one, the scale factor is small at first and then increases slowly over time. But for this system, I prefer to use the pulse out template. This will scale up rapidly at the beginning of the particle's lifetime and then scale down towards the end of the particle's lifetime. With this, I have found that I prefer to spawn only a single particle, so I will go back to initialize particle and make a few other modifications. Instead of specifying min and max lifetime, which is set at random, let's choose direct set. 1 second is fine. Then under mesh scale mode, I will select uniform. This will give me more predictable results. I don't want random behavior when I only have one particle spawned. For the mesh uniform scale, I will set that to 1.2. Finally, under spawn burst instantaneous, I will set the spawn count to 1. Compile and save. Open the basket blueprint again and specify pedal lost particles v2 to assign to the pedal lost particles pointer. Compile and save. If we play test, we get this kind of effect now. I just wanted to demonstrate some of the options. Again, play around with those settings, and if you are worried about the fact that you may lose an effect that you like, then duplicate the Niagara system and create multiple versions, as we have done here. Throughout the module, I mentioned that we have prefixes for different asset types, such as BP underscore for a blueprint, WBP for a widget blueprint, and so forth. Similarly, we want to provide our Niagara systems with the appropriate prefix. Let's navigate to the Niagara folder. If I right-click in here, notice we have this FX section. In here we have different Niagara asset types, such as the Niagara effect type. We also have the Niagara emitter. Now the prefix for that is FXE, and then we have the Niagara function. The prefix for that will actually be FXF, and of course those will also be followed by the underscore. Now in these lectures we created Niagara systems, and so the prefix for those are FXS underscore. Of course it's the same asset whether you use the shortcut here in the create basic asset section, which is just a shortcut since it is commonly used, or the option in the FX category, you get the same asset type. For now we are not concerned with the Niagara emitter and the Niagara function, so let's add the FXS underscore prefix to all of our Niagara systems here. Finally, we will make sure that our asset is still assigned in the basket blueprint. Compile and save. And that is going to wrap up this Niagara particle subsection. It was just a quick introduction, but I hope you have found this useful for your own projects.